Today we're going to be talking about entropy and the short story, The Last Question by Isaac Asimov. And by the end of the episode, you'll see how those connect. Yeah, we're going to start off with a discussion of the topics of energy and entropy in the physical sense and see if we can get to some kind of clear definition of what they mean.
Cool. Let's do this.
Well, I was reading a lot about energy last night, and it's a very confusing topic. But one thing that I kind of had like an insight about that I thought was really interesting is like energy, it's kind of this physical idea that seems to like unite everything. Like you can like start with energy as being this like literal force, like with a direction. Like if you apply force on something for a certain distance, like that's energy. But energy is also heat, and it also has this like electrical definition, and it just like unites all these physical phenomena and all these domains where it wouldn't be obvious that things would connect. I mean, I know it's kind of like a 19th century insight, but it seemed really interesting to me.
Yeah, exactly. So I guess energy is kind of akin to something like mass. And actually, I guess E equals mc squared dictates that you can convert between mass and energy. So they actually are the same thing if you do some relativistic stuff. The way the universe works is there was all this energy at the beginning of the universe. And I guess that's when the universe was sort of maximally ordered. And then sort of from that point, there's been more and more disorder that's been introduced into the universe. And then until eventually the universe ends or something like that. And we have a heat death where everything is maximally disordered or maximally chaotic. So we can understand, physical reality using energy and mass. And we can also, there's also a lot of like metaphors, like sometimes you feel like you have more energy and sometimes you feel like you have less energy. And
I mean, is that a metaphor though? Like, isn't there like a literal sense in which like we're machines that process energy, and sometimes we have like large stores of potential energy and sometimes it's depleted?
I don't think it's necessarily a metaphor. I think that we do at sometimes more than others have more energy. One way that I like to think of energy, and I'm not a physicist in any sense, but it's just in terms of movement, like movement of particles and like movement of systems in general. And when you're talking about like potential energy, I think that's like the balled up potential for things to explode. And sometimes you have less of that going on than others.
I think this idea that the universe is slowly running down into a heat death, I think it's a really weird idea. I mean, maybe it's true, but it seems like they've kind of just taken this graph and it says, okay, so there was, things were a little less chaotic 5 years ago, and now they're more chaotic, and we just expand that out and have this kind of straight graph, and we're like, yeah, once upon a time there was the Big Bang when everything was ordered, and then at the end of time everything will be completely disordered. And it seems like this overly simplistic way of looking at the universe. Like it seems to be assuming way too much than what we have of human knowledge.
Possibly. I don't think it's just an assumption or like an extrapolation from a graph, though. I mean, what we're getting into now is the idea of entropy, which is a word we haven't really used yet, but that's what we want to be talking about a lot in this episode. And entropy, Second Law of Thermodynamics, is basically this idea that energy will continue to dissipate. And it's not just because we've looked at the past and seen that things were more concentrated in the Big Bang and now things are more spread out. It's more about the idea that given that like particles and matter could be arranged in like any possible way for them to be that's consistent with the laws of physics and how they can move, there's way more ways for them to be disordered than there are for them to be like ordered. Like, for example, if you drop a plate or something like that, it's possible that like all of those atoms could arrange themselves like back into the form of the plate, like hypothetically. There's like a infinitesimally small chance, but there's infinitely more ways that it could break apart and be disordered. And everything kind of works that way. Like if there's one ordered way where things are like kind of massed together, as things move on, it's very unlikely that they're going to like randomly, spontaneously arrange themselves in the way that we considered ordered again.
It's so unusual because it's such an anthropocentric way of viewing things, isn't it? Like our idea of order isn't objective. It doesn't have any reality outside of humanity, or does it?
Like it seems like one definition of entropy is there's this equation that entropy is basically proportional to the logarithm of the number of equivalent microstates of the microstate that you're in. So like what a microstate is it's like if we take the universe at this exact time and we take like certain necessary physical constants to describe it, how many other universes are there that have equivalent physical constants? So like if you're looking at like particles in a box, like if you take like a certain number of, if there's a number of dimensions you need to describe the particles, like heat, pressure, if you take, let's say there's like two variables that you need to describe the particles with perfect accuracy, then if you take the number of other states that have like equivalent values, like maybe like the particles are reversed from each other, but they're still in the same position, the entropy is the number of equivalent states. This logarithmic to the number of equivalent.
Right, exactly. Actually, that article that you sent from Physics for Idiots was really helpful. It does sort of explain it in a way that's really easy.
It's interesting because like an assumption with that definition of entropy is that each different state of the universe where all physical constants are equivalent in this way that the concept of microstates defines them as equivalent, the assumption is that they're equally likely. And that's like a necessary assumption for this definition of entropy to work. So I thought that was interesting because that seems to me to be like kind of a questionable assumption.
Mm-hmm. That seemed to be kind of a questionable assumption too. I thought Curt had a point though. I don't know if I would call it anthropocentric, but maybe sort of. When you're talking about entropy, like physicists are defining it in more of a concrete way in terms of order and disorder. They are defining order and disorder in a concrete way, but saying that something is ordered or disordered is also kind of a value judgment, like the way that we use it in normal everyday language. And I don't think that it's necessarily disconnected. Maybe from a different perspective, a perfectly dissipated universe where there's nothing is the utmost order.
I mean, I think like with the plate example, like one insight is like the plate, when it's together in one piece sitting on the table, there's only one way that it can be together, but there's like a near infinite number of ways that it can be broken on the floor. That's a more likely configuration for it to be broken on the floor in one of the hundreds of trillions of quadrillions of ways it could be broken. But that doesn't necessarily mean that every possible configuration of the plate being broken on the floor is equally likely, or there's not some other mechanism that makes it likely for the plate to exist as a whole on the table. Because if it was just that each of those were just equally likely based on their physical configuration, then we wouldn't really have plates at all.
Well, I think there definitely are forces that people talk about that like bind certain forms of atoms together. But that's all part of the process of entropy and these things dissipating over time. They're just dissipating through these certain forms. One article that we looked at was actually talking about the hypothesis, or I'm not sure if it was a theory specifically, that life was like an entropy machine. Basically, it was like a way for matter and energy to dissipate into heat, like through this system that we call life that becomes increasingly more complex and better at that over time.
It seems to be backwards. Like life is becoming more complex, which in a sense it means it's becoming more ordered, which means the entropy is declining. But you're saying it's an entropy machine, so it's
part of the idea is entropy is like the second law of thermodynamics says that entropy always increases in a closed system. And our situation here on Earth isn't a closed system because we're getting massive amounts of energy from the sun. So the idea is that we're kind of outsourcing our entropy.
Right. And it's not that entropy within the creatures itself is increasing. It's that the creatures themselves are machines to increase the overall entropy of the universe.
Right. But what's happening is the entropy within the system is decreasing and the system is getting bigger. And so you're getting this kind of, and this is why I thought the last question story by Isaac Asimov was so interesting, is because, and spoiler alert for all of you people who haven't read the ending, basically the story is, we're in the future and there's this computer that can solve all of humanity's problems. And there's people asking it kind of, once every few eons or whatever, hey, is there a way to reverse entropy? And the computer keeps saying, well, there's insufficient data to calculate, to provide a meaningful answer. But eventually, by the end, like when there's nothing left except this computer and some like subspace, conscious network or something like that, what's left over of humanity's consciousness or something like that, is basically just calculating for infinite amounts of time. Eventually it gets to this point where it says, let there be light, and it creates the universe again. And so the reason why I thought those two articles, the story, the last question by Asimov, and the article about entropy in life, I thought they were kind of connected, because it seems like what life is doing is it's creating this area of localized order, and it's exporting the entropy sort of outside of its system. But eventually it should run up against the boundaries of the system. And when that happens, it should have to become more and more ordered in order to survive. And it should, and maybe given a billion years or a trillion years, or just a countlessly many years length of time, maybe given just an infinite amount of time, eventually consciousness should be able to figure out how to reverse entropy or something like that. So
yeah, it doesn't quite make sense in a way, because like if you go back far enough, it's like if the second law of thermodynamics really is absolute, then like where does it start? Like what is the Big Bang, and how does that relate to?
Right, exactly. And that's why this conversation will be somewhat physical and somewhat metaphysical, because of course physics says, well, no, you can't decrease entropy, in the universe. Once a certain, I guess the specific question was, when a star runs out, can we recreate the star? When a star runs out of energy, can we recreate the star or something like that? So of course physics would tell us, no, that's impossible. But is physics wrong?
There's one point in the story where the guy is like, well, if the star's going to run out, I'll just make my own star.
Yeah, I wanted to say physics wouldn't say that it would be impossible for you to recreate a star after a star ran out. It's just that
you'd have to use like the remnants of like 10 other stars or something like that.
Exactly. And it's that overall things tend towards decay, or things tend towards.
Well, and I think importantly, the amount of energy that you would get from this recycled star is probably not as much energy as it would take you to take all of that recycled matter and put it into a star and create it. It's kind of like, when we recycle plastic bottles, there's actually a lot of energy that goes into taking that used plastic bottle and turning it into an unused, new plastic product.
I mean, physics doesn't say it's impossible to like create a system that will give you more energy than like the energy it took to create it. Like think of like a battery or something like that. Like when you're making a battery, the battery produces more energy than like the energy that was used to make it, I think.
What I'm saying is that the battery, the reason why that works is because you're gathering sort of potential energy in the form of minerals, which you put into the battery and use to construct the battery. It's the same thing that they're talking about when they're talking about, oh, we're going to find a sun, and the sun is going to burn, and that's going to give us energy.
Yeah.
We could go find gasoline. We could go find crude oil. We could go find coal. We could go find all these places where energy is sort of locked up, and then we burn it or whatever, or we put it in a battery and we react it with something.
And by burning it, you mean unlock it and let it flow out.
Right, exactly.
With the sun, if you could theoretically gathered all those hydrogen atoms or whatever, put them together and started the reaction, it would actually make this fusion reaction, and it would be a chain reaction, and it keeps going. So you do get more energy than you put in.
You're converting mass into energy. So a fusion reaction is you're taking hydrogen and you're fusing it together to make helium. Eventually, you only have helium, right? So either you have to go find more hydrogen and fuse that together, or you have to somehow turn the helium back into hydrogen. And so, yes, as Katie was saying, there's minerals and places where we can go kind of mine for energy. But once we exhaust all of those sources of energy, then all that we have is the sort of waste products from previous fires that we were using for energy. And so, and at that point, all we can do is really try to put it back together. And in order to achieve that, we have to use massive amounts of energy.
So I think maybe it's getting a little bit confusing because we're thinking about like separate objects. But I think if you think about the universe as a whole, instead of thinking about like mining for individual things, what we're really doing is we're looking for areas where energy is concentrated, so then we can dissipate it because it's useful to us as it burns. And we're looking to take these concentrated forms of energy and maybe make them in a way so that when the energy like expends or dissipates, that we harness some of it to fuel what we want.
That's kind of it. There's like one definition of entropy is related to heat that's transferred during an energetic process. So it's like there's this idea of like thermodynamic free energy, and the basic idea is that when you have like some kind of potential energy locked in, there's a certain proportion of it that's useful energy, and there's a certain proportion that's like basically entropy times temperature. That's basically like going to be lost. So it's like when you have fuel and you put it in an engine, or there's less entropy before that took place than after. So there's the same amount of energy after, but some of the energy has been dissipated as useless heat.
And an engine has a maximum efficiency, which is related to the difference between the maximum temperature inside the piston and the heat sink that surrounds the piston. So if you put an engine into a really hot environment, it won't be as efficient as if you put an engine into a really cold environment. But anyway, going back to what Katie was saying about how, what life does, I guess, is it finds these sources of energy that it can basically burn, or like our digestive system can almost be seen as like a fire. It's like this acid bath that we put stuff in, and it basically burns stuff and it releases all this energy, and that's how we run. But there's a way to reuse sort of waste products from the original reaction that gave us energy. And the way to do that is to kind of do some work and sort of put everything back into order. And then you can kind of like reuse that fuel. I think the work that it requires to sort of take something from a disordered state into an ordered state. I mean, when you clean up your house, you're basically reducing entropy. You're exporting the entropy of your house into the garbage. And, as waste heat, maybe you're using a vacuum cleaner, or you're using hot water or something like that. And so,
and your own body, the energy that you're burning from your own body, just doing the cleaning. Right,
exactly. And so you're taking this little pocket of disorder and you're converting it into a pocket of order. And then you're taking the disorder and you're exporting it to outside of the pocket. And so I think, sort of the process of life is that it's like taking little things, little disordered pockets, and being like, we don't like this. This is too unpredictable. Let's order it and make it more predictable. And that produces more life.
Yeah. Order it and make it more predictable in my own little bubble.
Right.
Exactly. Would it be possible to get to maximum efficiency, where you're capturing everything, and instead of just exporting, you're capturing everything within a closed bubble and reusing it and recycling it and allowing it to fuel itself? Is that hypothetically impossible?
I think it's not theoretically impossible that you could have an engine that is 100% efficient, which basically means, all of the energy that goes in comes out as useful work. Although
it'd be kind of like creating a perpetual motion machine.
It would violate the second law of thermodynamics.
No, because it's about the closed system, right? We're not talking about a closed system.
Well,
right?
so
no, that's what I'm talking about.
So the second law of thermodynamics says that entropy can theoretically stay the same. Okay, if entropy stays the same, that doesn't violate the second law of thermodynamics.
Daniel, I think I'd like to get a fact check on that one.
All right, I will look it up real quick.
Thanks.
Let us know. I mean, it's in the article. It's entropy is greater than or equal to 0.
Okay.
I mean,
So-
I think if everything was in a complete state of stasis, then entropy would be 0 in that moment. But I think you would almost need everything to be in a complete state of stasis, like no movement. In order
Yeah.
to-
So what they say in Ariel's article is that in order to have a perfectly efficient engine, the heat sink surrounding the piston would need to be at a temperature of absolute 0.
That's the third law of thermodynamics. It's that entropy approaches 0, or entropy minimizes as temperature approaches 0 Kelvin.
So yeah, I mean, it just and Chris already had stated it, but yeah, there's the second law is that total entropy of an isolated system can never decrease over time. So it's gonna I guess the amount of decay is going to remain constant until you get to 0, at which point it can't go anywhere further. But yeah, it'll never go below that point. Like you can't have negative entropy or increasing order. Is basically the statement that I'm seeing.
Okay, so it could stay the same, theoretically.
Well, it could stay the same if nothing's going on. Which seems a little bit circular, as if nothing's going on is
Right. Yeah.
Right.
But that's
Yeah,
that's the
makes
end
sense.
of the system. I mean, that's heat death, or that's the final equilibrium where nothing else is going to happen.
maybe this is showing my ignorance, but pre-Big Bang is kind of like an equilibrium, right? Like in the quantum world, we can have things kind of pop out of things that feel like stasis or equilibrium, right? As long as they balance each other.
That's actually
Yeah.
Daniel. Could we get a quick Google look up on that too? Just like what's the conventional view about like the entropy of the pre-Big Bang period? I know you can't say pre-Big Bang, but
Well, and there's a separate question too, which is like, so you guys know about Feynman diagrams where little particles are just popping into and out of existence all the time.
Yes,
And they're doing this by appearing at the same time as their opposite.
exactly.
And so they appear and then they annihilate, and then they appear and then they annihilate. So the question is, what effect does that have on entropy, or what effect does entropy have on that? That's another thing that I'd be curious about.
Well, that would be, yeah, I guess that is a question. My immediate thought would just be that would be going from like the equilibrium to some entropy.
Yeah, I mean, it seems likely that. Okay, so as Dan was saying, like, if nothing is happening, then nothing is happening. But if presumably if we're transferring energy from one form to another, that would mean like something is happening, and then I would expect. Like basically, the only way that you can get the entropy to stay the same is if the system is in absolute 0. And if the system is in absolute 0, then I don't see it as likely that the system is changing or doing some kind of work, you know? So that would be why you can't have a perpetual motion machine.
it sounds like it wouldn't actually violate the laws of thermodynamics for there to be something that was doing something and having neutral entropy and not being at absolute 0.
Can you give an example of
It
that?
wouldn't violate the law, but is it possible is another question.
Well, it's a start.
It would have to be so perfect. It would have to be completely 100% perfect.
Yeah, I mean, basically, in order to make a perpetual motion machine, which is, I guess, the same question as how do we reverse entropy, or a similar question, is basically you'd have to know everything. So you'd have to have a computer that literally like is the universe. Yeah, exactly. Just like in the story, or just like in Hitchhiker's Guide to the Galaxy, where like there's a big computer and it has all the answers and it just needs the question.
Even the computer itself would need to like be expending some energy in order to crunch the numbers, right? And wouldn't that add some stuff into the system?
I mean, yeah, but so basically, the idea is, so in order to power a process, you need some energy. In order to use energy, you basically have to take a system from a more ordered state into a less ordered state. And somehow during that process, you're dissipating some of that energy as heat, but you're also using some of that energy to do useful work. So I guess in the case of a computer, it would be, electrical work. Or, in the last question story, I guess they start building computers out of more and more sophisticated and presumably more efficient materials, right? So we're taking this computer and it's doing more and more stuff, but it's using less and less energy to do so.
I think, though, the idea of the second law of thermodynamics is that no matter how efficient you get, eventually all the available energy runs out.
Well, but what I'm saying is you can always take the energy and convert it into an even less ordered state. Use that energy to do some kind of work. Yeah, I mean, I guess eventually, the entropy will be maximized in the universe. And at that point, we just have everything is at absolute zero, right? Everything is basically motionless.
So I just wanted to clarify, like the first law of thermodynamics is that energy can neither be created nor destroyed. So I think we need to be careful about saying that all of the energy is eventually going to run out. Right. It's not that it's running out, it's that it's becoming so diffuse that
it's no longer useful.
Yes.
It's sitting there, but it can't be used to do anything because it's too chaotic.
The way I picture it is just like, say you have your room and there's different air pressure in different parts of the room, but eventually everything will settle and all the air pressure will be completely consistent in the room. And because it's equilibrium, nothing's going to move, right?
Right. Exactly.
Yeah, that's an increase in entropy. Okay, let's get it, Daniel.
Yeah, so there were two things, and so I thought a good source to take a look at would be Stephen Hawking's website, and he's got a lecture entitled "The Beginning of Time," and it goes on for a bit, but one of the bits towards the end is that you had the question, Ariel, of what did the concept of equilibrium look like before the Big Bang, and his takeaway is we can't really tell because there is basically like the closer that we get to observing conditions surrounding the Big Bang, the more the laws of physics appear to break down. So there's a bit that he has towards the end of the lecture that says that the beginning of real time would have been a singularity at which the laws of physics would have broken down. Nevertheless, the way the universe began would have been determined by the laws of physics if the universe satisfied the no boundary condition. And from just my...
Sorry, what's the no boundary condition?
That's just saying that there is sort of a beginning. So if you imagine a ray, there's a concept that he's talking about called the arrow of time. But he's proposing that it doesn't extend. It's not a line that extends in both directions towards infinity, right? So for his purposes, he's using the Big Bang as a starting point, or like the actual dot, and then the ray continues to go in one direction, because there was some hypothesis previously that basically after the Big Bang, the universe would expand to some outer limit, and then it would basically collapse back on itself as effectively kind of like an accordion, or just some kind of a weird balloon where the energy expanding from the Big Bang would dissipate to the point where the expansionary force would kind of collapse back into each other. So it looks like some scientists were saying basically a Big Bang happened, the universe expanded out, and then after a certain point it would collapse back into another hyper dense reality point. And then, they were also theorizing that maybe another Big Bang would come out of that renewed singularity. And then Hawking's latest understanding, or the understanding that he leaves in the lecture, is that recollapse probably isn't going to happen.
So basically, so a few things. I guess the first thing is the arrow of time begins at the Big Bang, and that's just because we don't understand how time works before that. Like there could be...
Well, time, not only that, but like time doesn't really work before that.
It could. It just would be a different version of it from what physics currently understands.
This is one other thing that I was able to look up, is that there are a couple of scientists One of them being a Julian Barber out of Oxford. Julian and their team are basically hypothesizing what's called a mirror universe. So Chris, kind of in the same way that you had talked about certain kind of particles appearing to pop into existence then out of existence. And then
Right.
We've observed, or some physicists have hypothesized, that basically the reason that can happen and not just break rules is that there's an antiparticle that does the opposite somewhere else.
Yeah, exactly. And people theorize that there's like an anti-universe somewhere, or that like dark matter is all just like, antimatter.
Yeah, so the hypothesis basically, it's theoretical because we can't do any measurements from before that period, is that they're effectively the hypothesis of the mirror universe, which I don't know that Hawking talked about, was basically when the Big Bang happened, there was a mirror image event where effectively time is running backwards from a maximally, I guess, expansive state to the maximally dense state. And
this would be in the mirror universe?
Yeah. And then so I don't know how we test that. But it seems like that would basically just draw the circle a little bigger in terms of what's considered the closed system, because
right.
in that scenario, all of the energy in the reverse side is just contributing to the starting point of what's going to dissipate.
And then I guess the other thing that you brought up is how the universe is going to end. I think there's two just competing theories on this. One is that there's going to be a big crunch, right, where everything comes back together and on itself. And then there's the heat death of the universe, where everything just kind of becomes maximally entropic and it just ends.
There's a few more than that, but like one thing that's interesting with this discussion of time and all the like entropy and the Big Bang and everything is like there's like an idea in physics or like a theory that the arrow of time, like the fact that time seems to have directionality, is due to entropy. That every other physical process is, if you switch around the equation, it doesn't really matter. It doesn't matter whether time is positive or negative, but in entropy it does. So it kind of makes sense then that if they say like there was no time before the Big Bang, it would make sense they would also, like there would be no entropy, or like the laws of entropy wouldn't apply.
Yeah, that I did find that fascinating. And another thing that I find fascinating is how the human mind seems to have this concept of time, and it seems roughly accurate. But I guess what that means is kind of on a macro level, our brains can sense the level of entropy or something.
Kind of. I think that our human sense of time and maybe time in general is just us sensing the way that things move in relation to each other, kind of in patterns.
Can you give an example?
Yeah.
Like the ticking of a clock, like the ticking hands of a clock. When we're looking at time, we're just looking at like the pattern of how the hands of the clock move in relation to like how quickly it takes me to like pick up this glass of water. And I know that it takes me about as much time to pick up this glass of water, or time, as if time is a thing. But
that's kind of what I'm getting at. Like time is a
about
thing in your brain.
Yeah, it takes me about like that. Me being able to pick up this same glass of water is like around the same interval as 1 second, let's say, like ticking the hand on the clock. And there's like patterns that we can pick up and then perceive time. But we perceive time faster or slower in different situations too.
Of course. And so what I'm saying is, yeah, I certainly agree with you that we have a relative sense of time for sure. And that's obviously, where I think it has to do with, I think all animals have like a certain limb length, and their sense of how long a moment is related to how long a pendulum, the length of their limb would take to swing or something like that. We have an absolute sense of time too, is what I was trying to say. We have this sense that time is happening.
I mean, I think like the idea of entropy kind of gives credence to the idea that time with its directionality it's an objective feature of the universe that we're perceiving. It's not like an order that we're imposing onto the universe. Like even though time is relative, and we know that, and we experience time in a relativistic way sometimes, but there's no creature, there's no person as far as we know like experiences time going backwards. Like there's no situation where you'd be like, oh, in that situation it happened backwards for me.
You wouldn't experience time backwards because of entropy, but like entropy is, these are really broad concepts that I don't have the words for, but entropy is kind of like the way things move. It's the way things go. And so like when we perceive time going one way, it's because things like do actually go that way. Like they become more chaotic over time.
What were you going to say, Curt?
I was just going to say, if you take a large amount of salvia, maybe you will. It's being reported to me.
It was actually in the Once and Future King. There was one of the ideas in the books was that Merlin experienced time from forwards to backwards. So his consciousness started at the end of his life and then moved to the beginning of his life.
I do think that time dilation could be an interesting topic if we're talking about entropy. I know that's just perception of time, but if you're talking about like the psychedelic experience or even, experiences unrelated to drugs, like you can perceive time to slow down, or I wouldn't say that you perceive it to stop, but it can stretch to the point of almost infinity in some forms of perception.
Yes. So I wanted to talk about subjectivity and entropy because clearly, as you're saying, Katie, our perception of how fast time is going by is dependent on our state of mind, and it may be just maybe different brains perceive time differently. Maybe larger people experience time as going by more quickly than like larger or like smaller people or bugs or small animals or something like that. But maybe entropy also, as we were talking about at the beginning, is subjective because clearly, one man's trash is another man's treasure. So trash is kind of like, I don't want this. I don't need this. It's this like waste product that, presumably I use to help introduce more order into my life, but now I'm discarding it and somebody else can deal with it or something like that. But for you, that piece of trash is like maximally entropic. It's just like, this is useless, right? It's too disordered or something like that for me to use it. But somebody else could come along and mine that thing. And one of my friends back in Colorado was talking about, I'm excited about the future of landfill mining. Like I think we'll be able to go in and like mine landfills and turn them back into useful energy using some, really futuristic, elaborate technique to extract, further energy out of this basically waste material. So I just wanted to introduce the idea of like, so time is moving in sort of a subjective way, depending on your point of view. And also whether something and how ordered something is also dependent on your own point of view.
Well, it kind of makes me think of like the phenomenon you kind of alluded to before, that different beings experience time at different subjective rates. Like one finding in that area is that children experience time by far the most slowly of any human beings.
Oh, I remember.
So, yeah, right? It's like
a year is forever.
Like 10 minutes in the car. Like,
oh God.
Yeah.
That's awful.
As part of the reason is because children have the most neuroplasticity, and I guess they're probably exploiting energy most usefully of any human beings because they're building themselves into being bigger creatures, and they don't have much to waste on. They're probably producing less entropy than adults, and particularly like decaying adults in old age. But there's ways that adults can like reach that, I guess you could call it like low entropy, slow subjective time state. And it's like ways it can happen is through psychedelic drugs, through novel experience, and through experiences like falling in love.
What happens after those things?
You experience higher neuroplasticity, and the subjective experience of time slows again.
During that experience, or also afterwards, your time is kind of permanently changed, or your perception of time is permanently different?
Definitely during. I don't know about after. I would imagine it either goes back to normal or gets into some kind of intermediary state.
Okay.
And yeah, in my experience, it kind of flows back down to normal, but probably everybody's normal is different. This is just an idea I'm throwing out. Maybe it doesn't make any sense, but I mean, if you're neuroplastic, you are kind of in a state of like constructing. I think like life is always either building itself or it's in a state of decaying. And if you're in like a neuroplastic state, you're kind of in a state of like gathering information and like constructing new connections. Like we are as kids, we're building ourselves. And then over time, that building process eventually hits a peak and stops and then starts decaying with maybe like little bumps along the road. But maybe we are perceiving time more quickly with entropy being the arrow of time, because basically we're decaying, we're becoming more entropic, and so our perception of time is speeding up.
Well, and I think a simple explanation is also just that, when you're 4 years old, you really only remember about a year total. Like that's all of time to you. And so the next year of your life from age 4 to 5 is going to seem like all eternity because that's basically what it is to you.
Well, yeah, I was going to say that that's true, but it's not just about your memories. Like definitely your experience in the moment of the passage of time is very different.
When you get to age 30, 1 year is just a 30th of your life. And so an hour is proportionally smaller than it would be if you were 4 years old.
Yeah.
That's not the only factor.
I disagree.
It can't be the only factor, because if that was the only factor, then a 30-year-old would experience time half as slowly or twice as slowly as a 60-year-old, and that's clearly not the case. Like there's clearly a bigger discrepancy between children and all adults than between.
Well, it's not.
It also wouldn't explain why you can experience seemingly infinite periods of time when you're falling in love or when you're tripping on acid.
Well, obviously obviously you have a sense of like I said, you have a sense of how long it takes you to swing your arm, from left to right. And that's always going to stay with you. And that's always going to be constant throughout your life. But there's also, you have these past experiences of certain stretches of time. And so, when you experience those earlier in your life and you haven't experienced them yet, they seem a lot longer than later in your life when you're like, oh, I've already done this a bunch of times. I know how long this is going to be. Have you guys ever seen that episode of Star Trek, The Next Generation, where Captain Picard and Commander Data are talking about the boiling water and how long it takes to boil the water? And Data says, it's a great scene. Data says, hey, I've heard that a watched pot never boils, or a watched pot, takes longer to boil than, if you don't watch it. And he's like, and I've been trying it, and my internal chronometer always says 51 seconds, no matter whether I watch the pot or not. And Picard goes, well, have you tried deactivating your internal chronometer? And then he tries it, and the water starts boiling really fast, and he's like, it's a great scene. But so the point is, there's that sort of subjective experience of time, which has to do with like our expectations, like how long is this going to take? If you're going to have to wait for an hour for something to happen, you're probably going to occupy your mind with something else, right? And the time is going to go by more quickly for you because you know what to expect. But if you're just sitting there, first of all, if you don't know how long that you have to wait, or if you have to wait a certain amount of time that you've never had to wait before, then you're going to start getting antsy and bored, right? Because you're like, oh man, I've never experienced anything this long. What do I occupy my time with?
Yeah, I'm sure those are factors, but I think there's other factors as well. Like part of it is that when you experience phenomena that's more salient, time slows down, because it's like, oh, this is important. I should spend more time on this. It's not really more time, but it's more subjective time. It's more mental energy concentration, more internal resources. And when you're a child, everything is super salient, because you're learning how to be a person. Whereas when you're an adult, you kind of already know how to be a person. And especially if you're doing something monotonous or repetitive every day, the saliency just bottoms out.
I'm curious what you guys thought of the wacky out of the blue hypothesis that maybe we perceive time more quickly, partially because we're decaying.
It's kind of similar, because when you have more experiences, then they stay in your brain. So it is like your brain is more fixed. So it's a related idea, but which it's like two sides of the same coin. One is physical and one is, psychological or something like that.
Yeah, I think it makes sense that if you're it's kind of it's a similar concept in a way, like Curt's saying, if you're building something inside yourself, then time would slow down. And that's because you're lowering the entropy within yourself.
Right.
Whereas if you're decaying, I guess it doesn't necessarily follow that things would speed up.
Well, the entropy within yourself would be increasing.
Yeah, and I guess if the idea that the subjective experience of time is a limited resource, it would make sense that it would speed up in those situations.
Maybe. It's a question of if our subjective experience of time is actually related to the arrow of time or the entropy within ourselves.
So does anybody want to talk about the new physics theory of life, where they talk about basically the origin and subsequent evolution of life following from the fundamental laws of nature should be as unsurprising as rocks rolling downhill? Basically he says, okay, we have this heat bath, which is the atmosphere and the water. we have the sun, which is basically just pounding energy on the surface of the earth. Basically from that, what you get is these little bits of RNA that kind of form themselves into structures which efficiently dissipate heat.
I think it kind of makes sense. I think it would actually not make sense to think that, well, I mean, obviously life arises from the laws of the universe. And it would make sense that it would be kind of a natural progression. The way that I think about life is just that, I know this isn't like the scientific definition of life, but in some sense, life is just like self-perpetuating systems or systems that replicate themselves in some way with like a little bit of alteration each time. And
that's part of the scientific definition.
It's part of the scientific definition, but not the whole thing, because there's other things that are self-replicating that aren't considered life. But I don't think it's that crazy or surprising that self-perpetuating systems would self-perpetuate and that we would get more of them and that as entropy increases and like new things get introduced into the system, they would become more complex and spiral into what we think of as life now.
Well, yeah, and importantly, like what life tends to do as it, what you always hear people say, I want my kids to have it better than I had it, like that's kind of, it seems like a central motif of life on Earth, like I want to reduce entropy in my environment so that my kids can have a more predictable and successful life.
Because if they do that, then you will self-perpetuate better. Like the systems that self-perpetuate most effectively will self-perpetuate.
Are the ones that kind of clear their environment and make their environment kind of to their liking, basically.
I thought it was interesting in terms of being a theory of like how life began on Earth. Because like I've always been like disturbed by the big gap there. Like it seems like we have like almost like a glut of theories explaining how when life exists, how it might change, but we don't really have any good explanation for how life initially began. Like the current explanation is basically that like primary abiogenesis, which is like life emerged through maybe random chance or maybe some mechanism that we don't know because it was struck by lightning or something. Like that's basically the theory. Like I'm not exaggerating, and it seems like this is interesting because it provides like a possible mechanism through which that could happen, which always seemed like it was lacking. And my understanding of what he's saying is basically that inorganic matter or matter itself, when it's in a situation where it's in a heat sink or when it's in a temperature sink and when it's receiving external energy, will configure itself such that it's most efficient at absorbing energy and dissipating it into its external environment. And that basically because there's that natural tendency of matter, that's why in the like primordial soup of the early Earth, you get like these atoms and molecules like reconfiguring themselves to become like these complex proteins and amino acids and DNA strands and eventually cells.
Yeah, and this goes back to, I guess this is like off topic, but this goes back to our discussion about AI and how at the time I was saying, well, to me it kind of makes sense that if you have the Earth and you have some water and you have some sunshine and you do this for 1 billion years, eventually, you're going to get sort of these structured systems which take in energy and dissipate energy, and eventually the structures will become, like you have just endless amounts of like water molecules and like carbon atoms and structures. And like you have so many chances with the sun just shining on the Earth for millions and billions of years. Eventually you're going to get something that can replicate itself. Yeah. And then once you have that, then you have life.
Well, not necessarily. If there's not a mechanism to explain why that would happen, it still seems very unlikely, which is why this theory is so interesting.
Yeah, I think the crucial point of the theory is that it's not just randomness. It's that statistically, like what the universe is likely to do is to take these.
The crucial part of the theory is that 1 billion years is an incomprehensibly long amount of time. Basically, given 1 billion years, anything is possible.
Right. Well, that's the crucial part of the mainstream theory, but we're talking about what this guy was saying, which was saying that there's like something inherent in the nature of the universe as it relates to entropy, where energy wants to take these concentrated forms and then dissipate, and that naturally happens even to inanimate particles if you put them in a heat bath under these certain conditions. So it's not, I mean, of course, like anything's possible over billions of years, but it's not just random. It's also directed by entropy itself. That was the innovation in this particular theory that we're talking about.
Or it's like universe wants to express itself in different forms or something like that, right?
It almost like takes away the need for there to be like volitionality in the universe, because it's basically just saying it's a property of matter that it organizes in this way. So it almost like, it almost does seem to like reduce like the like God in the gaps of that particular hole in science.
No, it sounds like it's introducing a God. It sounded like the opposite. But here's something interesting. You guys know Conway's Game of Life?
No.
Yeah.
Yeah. So Conway's Game of Life is like this. It's like a simple 2D grid, and it's like if this block is surrounded by 3 blocks, then it's going to disappear, and if it's surrounded by 4, then it's going to appear and become a block. It's very simple rules. And I like to imagine like what rules or what conditions or what time span would you need to have a simple game like this, which is it's like a 2D universe, in order to create something by chance that was self-replicating. And you can actually make things that are self-replicating. Like people have sat down and put the dots in the boxes to make a factory machine, a factory that makes factories and all this kind of stuff. But it seems like it kind of blows my mind to think about how long or how much randomness or what you would need for it to actually create life.
Yeah, I mean, obviously it's extremely unlikely that life would develop just on any random planet, because we've observed many planets and none of them appear to have life. That being said, it's kind of hard to figure out whether certain exoplanets have life or whether there are other forms of life that just are so different from what we're familiar with that we don't recognize it when we see it. But clearly the Earth was a fertile ground for this to happen. Maybe it was, exceedingly unlikely that life would develop on Earth, or maybe, as this article kind of suggests, maybe it was inevitable.
Well, if you believe in determinism, then of course it was inevitable all along.
But I don't believe in determinism.
Just long time spans and probabilities.
And things being in motion.
Yeah.
In the way that they are. So I read an interesting quote, and while I was doing some research for this podcast, and I've been furiously Googling it throughout this entire episode, and I cannot find it or who said it, but it was an interesting idea, so I want to stick it out there. And somebody else came up with this. I can't credit them right now because I cannot find the quote. But this person basically said that the purpose, their concept of the purpose of life was to try to battle entropy in their own little world and create meaningful moments and structures of order out of this chaotic universe. And I'm curious what you guys think of that idea.
Spot on.
I disagree, but I want to hear what everybody else has to say.
I personally disagree as well. Like, I know this is like kind of like heretical, but like in the way that like older ideas of science seem to mirror like the reigning philosophies of the day, it almost seems like entropy is like, it just seems to really closely match this idea we have in modern times of like, we're in like a nihilistic universe. There's like no life after death. You're just born, then you run down and you die, and nothing really matters, and there's no morality, and everything's going to end in like nothingness. I know that entropy is a real thing, but I do, I don't know, it seems nihilistic to me.
What Katie said?
The quote, and like
the idea of the purpose of life being trying to battle entropy. Well, it is kind of nihilistic, because if you make your own life's purpose, which is, you know, kind of a subjective, like meaning imbued thing. If you make your life's purpose to battle the second law of thermodynamics, that's, but okay. So here's like the way that I would frame it maybe. And I mean, there's more specific purposes and everybody builds their own purpose. But I think that generally, rather than trying to fight entropy and create order, I think that a more appealing purpose of life to me would be to try to roll with entropy and recognize that we're all in this process of like growing and concentrating energy and then like flourishing, and try to flourish into the most beautiful, complex thing as possible before the structure dissipates. Like try to make that process as glorious as it could be.
I mean, that's the same thing.
No, it's not. It's a really
yeah. How is it different, Katie?
Yeah, those are exactly the same thing.
No, it's not the same thing, because on the one hand, you're saying that you're trying to fight entropy and create order.
Yeah. So beauty is the opposite of entropy.
No.
Yeah.
No, not necessarily.
Yeah, it is.
No, it is to some people, and they tend to prefer very clean lines and white walls, and
that's some people's idea of order, but some people have a very boring idea of order.
I mean, an Alex Gray painting is like totally the opposite of entropy.
Yeah, me too.
Like
I agree.
Very, very low entropy object.
Okay, but then what about like a Jackson Pollock?
I mean, depends on what you think is beautiful.
Yeah. That's what I'm saying.
Okay, for one thing, I think like with Jackson Pollock, I think his paintings are meant to be not beautiful. There's like a whole movement in postmodern art that's around that, and so I don't know that that's
fair enough. I'm not like a huge Jackson Pollock fan or trying to say that he was the most beautiful thing. But okay, some people see the beauty in the anti-beauty.
But you're trying to make an argument that beauty is subjective.
Yeah.
Okay, so I agree that beauty is subjective. Let me just back this up. So basically, what you're saying is that battling entropy is not the point of life or something like that, because some forms of entropy are preferable to other forms of entropy or something like that. And I'm saying that's what life is. Life is taking entropy from within your life and exporting it to outside of your life. And going back to what I was talking about before with, okay, well, parents often say, you know, I want to leave a better world for my kid and my grandkids and so on. Even though you can't destroy entropy, you can convert the entropy within your life to a different form of entropy such that you find the world more beautiful. And when you die, it can keep getting better from there. So you make the world better during your life so that your kids and your grandkids can have a better and more beautiful and less entropic existence.
So there's two ways of going about life that you have to kind of flit in between, and different creatures do this in different ways. But you can try to change and morph your environment, or you can try to align yourself with your environment. It's not just about battling your environment.
Okay, I think there's like a few factors here to break apart in this conversation. Like there's one question that kind of surrounds the whole thing, which is like, is the state of our existence truly that entropy is inevitable and that we're moving towards the heat death of the universe and that everything will eventually be destroyed? Mm-hmm. Like that's one question. And then within that question, you guys are like on the like, you're kind of assuming that the answer to that question is yes. And then you're talking about like, given that question is yes, how do we deal with this like inevitable destruction and heat death of the universe and then nothing really matters? Which I think like.
I guess what you're saying, Katie, is that some forms of entropy, what was I going to say? Some forms of entropy are beautiful, I guess is what you were saying, right? Like allowing
and the process of the entropy itself.
Yeah. Okay. But and what I'm saying is that if something entropic, you know, or organic, to some people that type of a thing might not look beautiful, but to some other people that type of a thing would look beautiful and is actually the epitome of order.
You're talking about the two example of the world's most ugly tree. Is that's kind of what you're getting at?
I don't know what you're talking about. What's the world's most ugly tree?
Okay, there's this bit in Chuang Tzu where he talks about this tree that's just everybody walks past it and says, "Look at this tree! It's all over the place. The the branches go upside down and left and right. You couldn't even make a fishing pole out of that tree. And because of that, everybody leaves it alone. And Chuang-Tzu thinks it's the coolest thing.
Yeah, that's exactly what I'm talking about. I'm saying what brings your life meaning is by reducing entropy as you see it. If you see something as beautiful, then that's not entropy to you. If it's valuable to you and you can use it for something, then that's not entropy to you. That's order to you.
No, that's not necessarily true. You can find beauty in disorder. I do think that beauty is subjective and that you can perceive beauty in disorder itself. It's not just that like some people see things that other people consider disordered as ordered. It's like some people appreciate disorder and find the process of the breakdown really interesting.
Well, how do you define beauty, Katie?
I think beauty is a concept that we're pointing to an emotional reaction within ourselves when we experience a thing.
Like elation, something that inspires elation.
Yeah,
joy.
Something that inspires elation or joy or even love or something that inspires whatever we consider to be beauty, which is probably a combination of those things.
Uh-huh.
I mean, it seems like clear to me though that the way we interpret beauty is like there's maybe a subjective element, but there's also like people overwhelmingly tend to find similar things beautiful.
Yeah.
Like it's not that like, every random artist has a few random followers. It's like there's a small number of artists that have a massive number of followers and a large number of artists that have no followers.
Yeah, well, because some things are kind of biologically wired to inspire elation in humans, like things that will help us survive, like water and like fertile women and stuff like that. But we can have emotions based on things that aren't that way too.
Yeah, and what I'm saying is you have an instinct that's built into you biologically to maximize those things, which is the same as your instinct to minimize the entropy around you.
But I mean, even when we find, beauty in like something like, I don't know, like it's like for one example I was thinking of is like, we tend to find children very like beautiful and adorable. And it seems obvious why, like they're very low entropy creatures and they're full of potential and all these things. So they're forces of creation, right? They're forces of creation, which we find beautiful. And then when you look at like, and then if you look at people who are, let's say like very old and sick, we tend to find them less beautiful, but you can find beauty in those people as well. Mm-hmm. But when you're finding beauty in them, you're probably attaching to something that's still constructive, like a moral virtue or wisdom, or like there's still something in there, like a spark. Like you're not like it's unlikely that you would find someone who's old and sick and completely corrupt and completely lacking wisdom and like miserable to everybody. And
yeah, well, I mean, you can shift your perspective to find nearly anything beautiful, I think. But you probably are, like you said, calling to things that people find more or less universally beautiful. You're just creating a different story. Maybe.
Yeah, well, what I'm saying is there's a drive that everybody has to make things more pleasant for themselves and more predictable for themselves, and beyond that, to make things more pleasant and more predictable for their kids. So when you see like people say, oh, that work of art is beautiful, there's a desire to keep that work of art around forever, to kind of, I want this to still be here, generations after I'm gone, because it's a beautiful thing.
But not always. There's also things like mandalas and like monks who will draw an extremely ornate drawings in the sand in order to let them like be blown away and find beauty in that process, not only in the beautiful and ordered thing that they're creating, but also beauty in the whole overall structure as like a metaphor for life and the way that things come and go.
Yeah, it does seem to be in a sense, it's an exception that proves the rule, because there wouldn't be any point in destroying it if they didn't make something beautiful, right?
Right. True. But the destruction of it is part of what makes it beautiful itself. It's like Burning Man would not be nearly as
Yeah, I was going to mention.
if it was
Right.
all the time.
Well, and actually, the burning of art is a core activity of Burning Man. People bring their art installations to the playa, and then they set them on fire at the end of the week.
Yeah, exactly. They set their art on fire. They set their thoughts, like things that they want to release, on fire, like that. That's a huge part of the beauty too. That's a high entropy beauty.
Yeah. Well, so I think burning things and destroying things can be a really like satisfying activity. Like, I think there's a reason why like pyromaniacs exist, you know, like watching something be destroyed, watching something rapidly convert into from a highly ordered state to a highly disordered state. There's something satisfying about that. That's true.
Not just because of the fact that it's being destroyed, but also because like when you have an explosion or a fire or something like that, it creates all of these beautiful structures in the process of destroying itself that are so much more complex and organic and like amazing, and I guess you could say ordered, than anything that we would probably be able to like put together piece by piece. And I think that that's kind of what life is, and that's what I was trying to get at, is like this like process of creation and destruction makes stuff way more complex and like beautiful than we could ever put together.
Oh, but we get to participate in the process, and I think that's part of what gives life meaning.
Yeah, it's interesting. The example of fire is a really interesting example because it does kind of, I think you have a point that part of the appeal of fire is like its destructive force and its like burst of high entropy. Although, as Chris often points out, one cool thing about fire and the destruction of fire is it opens space for new creation as well.
Very good point. Yeah. So, I mean, sometimes the process, sometimes you have creative destruction. Sometimes you have, you know, because something gets destroyed, you have more room for more stuff to be created. So that's why I guess death can sort of be beautiful.
Yeah, I don't think that's all of it though. I think Katie has a point that like there is like a fascination with destruction and death and fire. All those things.
That was more on Chris's, but yeah. Okay. So I guess that kind of brings us back to the story, because in Isaac Asimov's story, like maybe I can just summarize it a little bit. Basically, there's humans in the future have created this supercomputer who's been able to harness the energy of the sun and basically can answer any question that people ask. And Chris went over a little bit of this, but people, as time goes on, they realize, like, even though it seems like we have infinite energy now that we can like harness the energy of the stars, entropy is always increasing, and eventually this is always going to come to an end. And is it possible for us to reverse entropy? They keep asking. And the computer always answers, there's insufficient data. And this gets to the point where entropy has increased so much that like humans are no longer even really in their bodies. Original Earth has been destroyed. They've spread all around the galaxy, and then they're just kind of floating minds. And then eventually the minds all merge into one. And then eventually the minds all merge into the next generations of this computer, so that you just have, the ultimate AC. And then it becomes nothing, and the computer is still there trying to answer this question until finally it decides to answer by means of a demonstration. Let there be light. So it's kind of the whole process of going through the heat death of the universe. And then I guess maybe we could say that Isaac Asimov was maybe promoting part of the Big Crunch theory, or basically saying that evoking God, or a lot of things, but
or that the new universe will arise from the ashes of the old universe.
Yeah, or that like like a phoenix. There's a lot of different metaphors there, but do we think? I mean, we have no way of knowing, but do we think that this whole universe and the destruction of the universe and the heat death or the Big Crunch or whatever is going to happen is making way for something else? Or is it just, that's it?
It's interesting because like you talking about like the mandalas and stuff, it almost seems like there's like almost like an Eastern perspective and a Western perspective. Like it seems to like a lot of Eastern religions seem to take the tack of like, yeah, there's going to be the heat death. Everything is finite and going to be destroyed. Everything gets destroyed eventually, and we just might as well make the best use of it in whatever way we can while we're here. You know,
they make it sound a little bit more beautiful than but
I know, but like that seems it's a general philosophy, right?
Sure.
Okay.
It's like the general philosophy without any of the flavor, but yeah, we can give it that.
Okay, well, I can rephrase it to try to have more flavor, I guess, but
No, it's cool.
I'm not going to.
Okay, we're moving on.
So anyway, and then there's like the Western perspective, which is more like there's the future, like the future is not determined. There's some things which are eternal, and there's a purpose to everything, and there's a point, and we're working towards something. And I guess like Asimov takes that a step further and is like clearly the thing that we'd be working towards as like species and civilization and planet is reversing entropy.
Yeah, I mean, to me, like, yes, there might be nothing after this. You know, there might be nothing after I die. There might be nothing after the world ends. There might be nothing after humanity. There might be nothing after the universe. But I think what keeps life going is the hope that that's not true. The hope that there is something after, that we are contributing to something greater. So, you know, maybe it's not provable, you know, or even like intelligible, like, you know, what that thing might be. But to me, you know, just sitting here and thinking, oh, we know everything and we're all, you know, we're going to die someday. And so we might as well just not do anything, right? Because that's what logically follows. So to me, that's to me, that's really depressing. And I don't even want, like, I did that for a bit and I was like, okay, this is stupid. Like, I'm not motivated to do anything because I'm like, well, it all might come to an end someday.
Now Katie's going to defend Eastern philosophy.
Yeah, yeah. I feel like we've got like two teams, East and West. Go on, Curt.
Wait, really? I'm Eastern.
Anyway, we don't want to get into these broad generalizations.
Wait, what are you saying? Are you saying I'm not? That wasn't Eastern?
No, you're expressing an extremely Western philosophy right now, in my view.
So what do you mean? Can you elaborate?
Okay, so we're not. I mean, East and West. We'll use these terms, but from an Eastern perspective, you wouldn't be like working towards some goal and it's meaningless if it's going to end someday. And that's not how I see it either. Alan Watts has a really nice thing about this. I know he's like kind of the stereotypical translator of the Eastern philosophy to the West, but he has a really nice clip from one of his lectures where he's talking about people are always like searching for the goals in life and trying to get to the next stage and the next stage and the next stage and the next stage. He's talking about life success in this. And then eventually, you know, people will meet all their goals, you know, the ones who succeed, like maybe they've got the money, they've got the family, and they'll realize they didn't feel any better than before. They don't, you know, they've arrived, but what was the point of that? And he says, and I agree with him, that it's a mistake to think about life as trying to arrive at some goal, where instead it's more like a musical thing, and you're
that's not what I said
along the way.
Yeah,
no, that is what you said.
No. I said it would be really unsatisfying to sit here and do nothing. I'm not saying that.
But you said that it would be depressing to think that all of this is going to end someday, and what keeps life going is thinking that there's some greater purpose to it all. And what we're saying is the opposite. That it's about enjoying the process and dancing along the way, even if the song is going to end. The song is not pointless because it ends.
That's what I'm saying. That is in complete agreement with what I said.
Maybe I misunderstood what you said, but you said what? Did you not say that what keeps life going is the hope that there's a meaning to it all?
Yeah. Because why would you dance if there wasn't, Yeah.
No, okay, so we're not in agreement at all.
Let me mention a couple of things. So one thing is like in Hinduism, the destructive force is Shiva, and Shiva is also the force of consciousness. So Shiva is like distilled consciousness, but it's also the one who just comes in and wipes it all away. So within the consciousness is the potential for everything. Like sitting there in meditation, a thought pops into your head, and like like in the Bible or in the end of the story, let there be light. And another thing is what when I was in the temple in Wat Tam Krabak, every morning we would go out and we'd sweep with the broom. And sometimes one of the guys would come to me and it's like, "Hey man, why don't you're sweeping so slow. Why are you doing it like this? Do it like this. It's more efficient." I'm like, that's not actually the point of this. All these leaves are going to be back here tomorrow, right? That's not why we're doing this. There's a very different purpose to why we're doing this. And it's not to clean the road. It's just to be exactly where you are and sweep and focus on the sensations, and that's it.
I feel like there's two ways you can kind of look at that kind of thing, right? Like you can kind of look at that kind of thing as like when you're doing that and you're learning that ability, you develop a capacity to go and do other things, and those other things are the important part versus like the capacity itself is the important part.
Yes. Yeah, well, that's another way of looking at it. Yes.
Yeah, I do think for me, it's ideal to try to switch between the two perspectives. I don't want to have no like long-term goals or meaning or purpose, but like when I'm constructing those goals, I want to recognize that I'm constructing those goals because I think that those goals will give me an experience in the moment that I want more, not because of the end goal itself, if that makes sense.
Yeah, well, but at the same time, like if I'm sitting there being like, this is a pointless activity, I won't be enjoying it at all. Like that's like, there's no way for me to enjoy it if I'm just like, this is utterly pointless, like.
Well, yeah. I don't think that's really how monks are doing it.
Well, that's not how I did it. I mean, like I said, I knew the leaves would be back tomorrow.
You're sitting there going, I'm enjoying this, then that's definitely, its own type of meaning.
Yes.
But a lot of times the reason why you're enjoying it is because you feel like you're contributing to something. You feel like you're making progress towards something.
Yeah, but not necessarily in this case, because all the progress is actually just being there.
Well, the progress is within yourself, though.
But it's right there in that moment. Like, as soon as you do it, it is there. And it's not like you keep, like, trying to level up necessarily. I mean, you can, but that's not exactly what it's about.
Yeah, I think the Western perspective is you're trying to improve your environment in some way. And the Eastern perspective is you're trying to improve yourself. Or you're trying to see how you're already suited to your environment or something like that. And you can just be. And the Eastern philosophy is being, and the Western philosophy is becoming, right?
Right.
Yeah.
Well, I think both are really actually pretty cool.
Yeah.
Well, yeah, I agree with both of them as well. And I do hold both I think I do hold both philosophies in my head at the same time, like you were saying. But I just don't see how what I said was more Western than Eastern.
Because basically you're saying like, yes, by being, you become better. And that's why it's great.
Right.
I mean, yeah, that is why it's great.
But it's
not.
I
kind of agree with what Chris is saying. Like it's like the Schopenhauer thing, which is an idea that comes from the West. But he asked the question of like, if nothing matters and there's no morality and there's no ultimate purpose, then why not just kill yourself? And he was like, yeah, you could probably just kill yourself.
Yeah, exactly.
Yeah, but then
You totally could.
Camus.
I don't think that these two views are incompatible. It's just kind of funny because it's like, okay, I think it's showing each of our biases because I think we all hold the being and the becoming, but we have kind of preferences or or like it's a cyclical thing, but we have different starting points and ending points in the way that we chunk it, because you're saying like by being you become better, and we're saying by becoming you can be better.
Well, it's like the yin and the yang, where they each contain each other. They each contain the kernel of the other.
I guess what I kind of wondering is like, if you don't have any kind of like in your view, in Curt and Katie's view, like, why value being? Why value any emotional state? Why value any of it?
It's just cool. That's it's hard to answer. Yeah,
it is hard to answer that. Why value becoming? Why value doing these so-called great things if it's all pointless in the end?
Because it might not be pointless.
Yeah,
Because
exactly.
at the end of the universe, we might build something that creates the new universe out of the ashes of the old universe.
Okay, and then if that is eternity inherently more valuable than things that are temporary?
Hell yeah, it is.
Everything you do is eternal. It's the consequences of everything you do stay forever. They're never erased. They never can be.
And don't get me wrong, like I also think that eternity would be really cool, and I kind of share that goal. Like that would be really awesome, because then you could continue the experience of being, but I see like the subjective experience as the most important thing, because that's the only thing that is experienced. That's why I value the being, because the being is all there is to the beer.
I don't really think that's true. I mean, I think the idea with like focusing on the becoming perspective, or focusing on this idea of purpose, is like it's simply the idea there's a meaning and a purpose and an intention and a direction that like supersedes our individual selves and even our identity as a species. Like there's something greater than us, and that we can like, it's possible to have a sense of what that is. And I guess at that point we have the decision of either going along with it or of rebelling against it or of ignoring it. But that's a meaningful decision to make. Like that's an idea. And you can say, well, why not just rebel against it? And the answers why aren't clear. I mean, you can say there's a greater purpose that's in line with existence, that supports existence itself, the continuation of existence, and maybe the existence of another universe after this one. And then you can ask the question, like, why should we be on the side of existence? Why not be on the side of non-existence? But I think looking at it that way, it's still like a different perspective of looking at it, like grappling with it at that level, than of just looking at it from the purely individual perspective, which in my view misses out on so much.
Yeah, I think you do have to look at both. I'm not trying to argue against, it's just that it seems like the being perspective needed some help.
Yeah, so I do think there are two extremes. There's the being perspective, the 100% being perspective, which is, everything is for my own pleasure. Everything is so that I can see things that are beautiful and enjoy life, and then there's the extreme becoming, I guess, perspective, which is, nothing inside me matters. Everything, I should only commit myself to things that are larger than myself, basically I am nothing. And so, yeah, there's this, so all that I am is like a contribution to some eternal process. Right. So clearly, the truth, what I like to focus on, I guess, is somewhere in the middle, where I matter as sort of my own universe in a sense. And so my pleasure and enjoyment are important, but also there's something bigger than me, and also that's important too.
Yeah. Yeah, though I did think it was strange the way you put those two extremes. I didn't think I would put it like that. But yeah, fair enough.
Well, how would you put it?
The pure being perspective would be like just focusing on the present moment and enjoying it, for lack of a better term. And maybe the extreme becoming, well, that's actually, I don't know how I would put it. I guess it might be similar to what you described.
My view of the extreme becoming would be like you're imagining an image of something that you consider beautiful or worthwhile, and you're trying to construct that at all costs, even to like the sacrifice of your whole life, may be miserable.
Like maybe you never stop and just take things in. Like once you climb the top of a mountain, you're like, well, fuck this. I'm going to go back down again. I got to climb it.
No. Yeah, actually, I had a really great experience with when I was hiking the mountains with some friends. Where one of my friends was like that. We'd get to the top, we'd go, let's hike that, and we'd hike to the top. We get to the top, we'd be like, this is a great mountain, and he'd be like, but look, guys, there's an even higher one over there. Let's keep going. And I'd be like, but I just want to enjoy where I am. And
yeah.
Right, because why did I climb up this mountain anyway?
Yeah, exactly. Like the whole point of climbing the mountain was to get to the top so that I could sit down and enjoy the view.
But that's the thing, because I don't think the point of the climbing the mountain was to get to the top. I think the point of it was to climb the mountain and every point of it, including getting to the top, right? And
well, yeah, but the way that you motivate yourself to get to the top is the way that you motivate yourself to do the hike is by picturing how awesome the view is going to be from the top. So, I mean, maybe the hike is fun, or maybe it's not fun, maybe it's a shitty hike, but the way that you keep yourself going is you're picturing what's going to come after.
Or you're trying to be in the present moment and like appreciate every single vista point along the whole way. And then you see them getting better and better and better as you go up.
Yes. And enjoying the challenges of it.
Yeah.
It's a little bit like there's a few confounds here with this idea of the being and becoming perspective. Because if you're in the becoming perspective, like you could be in the becoming perspective because you want to experience the subjective experience of like the process of becoming or whatever it brings. Like if you're like, I want to climb the mountain because it's going to be so beautiful at the top and I'm going to have a really nice moment. Like that's kind of a pretty different perspective than I want to hike this mountain because I'm going to like get in shape and I'm going to climb more mountains and then that's going to help me reach my goals. Like you can have a goal-oriented or not goal-oriented becoming perspective.
Or you could have a becoming perspective that's literally just trying to check off achievements like you're gathering badges in a video game.
Okay, here's another thing that I wanted to bring up before and I forgot what I was going to say. So basically we were talking about, I don't remember, one of our previous episodes, like one of the Crypto Hippie episodes, we were talking about how if you sit there and just be, entropy is, and this ties into entropy too, entropy is always increasing. And so if you just sit there and be, then you're almost like a party to stuff falling apart, right? You're like, if you're not doing anything to combat the stuff falling apart, it's just going to fall apart more and more and more until you die. Like until you have so little control over everything that goes on that you literally just die. Right. So I think part of becoming is trying to get somewhere where you can relax enough to just be, right. If you're always just sitting there and never trying to become anything more than you are, then your life is going to get riskier and riskier over time.
And that's a really great point. Like it's part of this idea of why like the word stagnation is like a negative word and not a neutral word. It's like exactly. if you're not growing, you're on the slow decline because of entropy. And it's interesting because like that idea of like your friend being like, we just climbed a mountain, let's climb another mountain. Like there's almost something about that that's like very fundamentally human. Like even at the level of our neurotransmitters, like when we work really hard and achieve a goal, it's like there's a burst of like, serotonin and dopamine and adrenaline and all this, but it's not like it lasts forever. It's not like you're in a permanent state of bliss after that. Like it quickly declines, then you have to do something else.
Yeah, and even if you're doing sort of Eastern things like yoga or meditation or what have you, there's sort of a being and becoming pendulum in that too. Because, if you're sitting there meditating, eventually you're going to get to sort of a dead end and you're going to be like, or if you're on a hike, right, maybe you're looking at some tree and you've been looking at it for 5 seconds. Okay, well now I'm going to look at this tree instead, right? You're just shifting your gaze, but you are becoming, in a sense. You are sort of changing your situation in order to improve it.
Yeah, absolutely. I mean, without the becoming perspective, we would be dead. But like, if a human if a human was somehow born into a culture that had no becoming perspective, you would just like, you would just get hungry and probably, dehydrated and die. Like you do have to do some things and
right, exactly. So I think there's this kind of biological drive in all living things to become, in order to be.
Yeah, but then at a certain point, I think it's important not to neglect the being perspective. And maybe this is because I do see death as probably inevitable. It would be really cool if we could become immortal, and I think I would embrace that. But if you don't embrace the being perspective, then when things do break down because you can't beat entropy, or at least we don't think we can beat entropy, or we haven't figured it out yet. When entropy takes its toll, your existence will be miserable if your only perspective is becoming.
It's actually Carl Jung talks about that in Modern Man in Search of a Soul, because he says that that we need a different psychology for young people and for old people. So when the sun is rising in the first half of life, is it basically the healthy thing to do is to focus on what we're calling the being perspective, which is like achievement and activity and being out in the world and striving for things and passions and all this stuff.
Becoming.
Yeah, the becoming perspective, the becoming perspective. And then second half of life, when the sun is setting, the healthy thing is to be, to turn more inwards and to become more still and to be more basically like Buddhists, like living in the moment. And that when either a young person, and that when it becomes messed up, like when a young person is trying to be too isolated from the world, or when an unproductive, and when an old person is trying to still, date 20-year-olds or whatever, then that's when you get pathologies.
The expression, I think it's a Chinese expression, and it goes in good times be a Confucianist, in bad times be a Buddhist, and in old age be a Taoist. So it's in bad times you learn to deal with your suffering. In good times you learn to be a better person or be more generous and more fulfilled. And then in old age you just chill. So,
yeah,
that kind of makes sense.
Yeah, but so I wanted to address what Katie said about how, if you are always looking for a goal or something like that, and then entropy takes its toll, as it inevitably will, then you'll have a miserable existence. And to that I say, well, if you didn't die, then maybe you have a temporary failure, and of course that happens to everybody all the time throughout life. They strive towards some goal and they fail, right? And then maybe they're depressed for a while, and yes, their experience may be miserable for a while, but if they're not dead, they can pick themselves back up and keep trying. If they are dead, then it doesn't matter, right? You're dead, so you failed, but you really don't have an experience of that. So, yeah.
Fair enough. But I don't want to experience a slow, inevitable decline where I feel like I'm failing. And I'm not really worried about that. That's just not the perspective that I'm going to take.
Yeah, I would say a slow decline would be really miserable, but
well, and that's the trajectory that we're all on eventually,
unless we go out in a burst of youthful glory.
Right. Right, we could go out in a burst of youthful glory, or we could reverse entropy.
Yeah, or maybe both.
That's all we have to do. One of the simple. I was going to say about what you said, Chris, about becoming in order to be. I did think about that, in that month I was chilling in the countryside in Portugal, because I had goals. I was like, all right, well, I want to get 100 hours of meditation this month. And I was like, that's so funny that I would set goals when I'm trying to just be cool and just enjoy stuff. And also it's like I wouldn't have had that opportunity to travel to Europe and just sit for days if I hadn't been very fortunate, if I hadn't had an active brain and figured out a little wealth and all this stuff. So yeah.
I think it would be fun for all of us to take our best guesses at the last question. Like if you just had to take a bet right now, somebody else's money, but you've got to do it. Can entropy be reversed? What do you say?
Yes, absolutely.
Yes.
Probably, but I don't think I'd want to do that. I think things come to their natural end, and then something else would come up, or maybe it won't. Who knows? But things generally come in cycles, so it's no problem by me.
I don't know. I kind of like the way that the story put it. Actually, I don't know if it's fair to say that in the story they reversed entropy, or if it got to the point of complete dissipation and stasis, which was kind of like that.
A perfect order.
A perfect order,
Yes.
from which everything can explode again. I don't know if that's. I wouldn't say that's a reversal, but it's a continuation. Yeah, I think things continue, if I had to guess.
Yeah. I mean, to me, whenever I've thought about the limits of the universe, it never made sense to me that the universe has physical boundaries. It never made sense to me that the universe began at some point and will end at some point. Like, it doesn't make sense to me that there are 12 dimensions. Like, to me, it seems like there are infinitely many. Like, you can zoom out infinitely far or zoom in infinitely far. Like, it doesn't make sense that there would be boundaries, is I guess what I'm saying. So, yeah.
Well, cheers to a new beginning then.
Yeah.
And on that
I'll
note,
cheers to that.
On that note, thank you everyone who listened all the way through with us. Please, if you like this episode, like, subscribe, and so on and so forth. And yeah.
And we love you.
We love.
That's a lot.
Oh, we're not doing peace and love, right? We're doing we'll have to come up with a different slogan.
Entropy and decay.
Yeah, we wish you low entropy.
Curt and I wish you high entropy.
How about beauty? I like how that beauty was kind of opposed to entropy, at least in my view.
All of it.
Have a beautiful rest of your week.